Hi guys, so tonight I'm going to be talking about reactivity in React and Vue. So we're going to do a sort of high-level overview of how the frameworks work and how they both implement reactivity, which is sort of the core of the frameworks. So my name's Edd Yerburgh. I'm a software engineer at the BBC and I'm also part of the Vue core team. So out of interest, who here has used React before? Okay, quite a lot of you. And who here has used Vue before? Okay, not so many of you, but still a few of you. So we're not going to go over the details of how to use them, but I'm just going to try and give you a high-level overview of how the framework works. So from writing your component to what happens when a user clicks on or interacts with your component, and how that triggers an update in the DOM. So Vue and React are really similar frameworks. They're both the Vue layer. So they're sort of the V in MVC. They both use component-based architectures. So the sort of philosophy is that you use these composable components to build up your application. And they both use the virtual DOM, which is like a slight oversimplification, but basically they both use this thing called the virtual DOM, which we'll talk about later. The biggest difference between them is how they implement reactivity. So first thing is components. So this is a Vue component, right? It's just a template, and it's going to render a div with an h1 tag with a value of 0. And we can use this component once we've registered it in a Vue app just if you look at the template, we can just use it like an HTML element. So this is the sort of the composability of Vue. Under the hood, Vue compiles that template string into a render function. So if you look at that function, it's quite confusing at first, but basically we're calling this function called createElement, and then we're calling it with a div and an h1 and the value. And you can sort of imagine that this is like telling the DOM what it should do, and it's creating these elements and then putting them into the document. Sort of like document create element, but a bit more complex. So yeah, we need to talk about the DOM to talk about these frameworks. The DOM's the document object model. So once your HTML is rendered in a browser, it gets added to the DOM, which is sort of an interface for reacting with a document. It's how you have reactive web pages. So this is the HTML that our component earlier would generate. The DOM uses a tree data structure, so it would take that HTML and then render this tree of data, where you have the parent div node and then a child h1 node, and in the DOM a text node is also a node, so you have the 0 being the child of the h1 node. So earlier I was saying that you could imagine the render function basically just calling document create and creating these divs in the DOM. But the problem with that is it's really expensive to update the DOM. So if your application was updating the DOM every time some state changed in it, your application would seem really sluggish to users. So we need to be a bit smarter about it. And that's where this thing called the virtual DOM comes in. So the virtual DOM is exactly the same as the DOM. It's a JavaScript representation of the DOM. And that might not make sense to you. It's easier to sort of understand it if you think of it as literally just an object. So this is a really simple example of a virtual DOM, where we're describing the same HTML structure as we were creating earlier in our component. So you have this object, we've called it vnode, and each object has a type and a children array. And inside that children array, it can have more of the same kind of object. So that's a really simple example of a virtual DOM. It's just a JavaScript object. So our template from earlier had this render function, and I said that createElement could be almost thought of as creating an element in the document. But what it actually does is it generates the virtual DOM. So the sort of process of an application that uses React or Vue is to generate this virtual DOM from the components and then update the DOM using the virtual DOM. So instead of just creating a new DOM structure each time the application is re-rendered, it'll at some point call a function that sort of diffs the virtual DOM against the real DOM and only makes changes where there's a difference between the virtual DOM and the real DOM. And this way we minimize the amount of changes we have to make to the actual document, which makes our applications a lot faster. So when you create your application using a component, you have this initial render where you render the virtual DOM, and then the React or Vue framework compares your virtual DOM to the real DOM and updates the real DOM to make it in sync and to reflect the virtual DOM. So hopefully you guys are still following me. So the virtual DOM's great, and we had that component that rendered the h1 tag with the 0 value inside it, but that's not really much use alone. We want to add something. We want to add a bit of complexity. We want to add this thing called state. So state is a way of storing data inside a component. This is our component from earlier. I've moved it into a Vue single file component format. So we have a script block, and we can extract the template into this template block. So this is the same component, and it would render the same HTML. And now we can add this state. So if you see in the object, we've added a data function, and that returns the initial state of our component. So here it's count, and count set to 0. And then inside the template, we're going to render the count value. So at the moment, this does exactly what our component from earlier was doing, but it set us up to be able to add in some interactivity. So the next thing to do, this is a counter component. We're going to add in a button. And if you look at that button tag, you can see that there's an @click property. This is basically an on-click event, and it says that when you click on the button, update the component's state, the component's count state, by 1. And by doing that, because Vue picks up that the state has changed, it's going to re-render the component, re-render the virtual DOM, diff the virtual DOM against the real DOM, and re-render. So this is an example of the component that we've got so far. And you can see that by clicking increment, we're incrementing this state. So our DOM looks a bit more complex now. We have a button and an h1 tag, and they both have text values. So if we just go back, we see that we initiate with this 0 value in the h1. And then if a user triggers a click on the button, it's going to update the count value, which is going to trigger a re-render of the virtual DOM. And the virtual DOM is going to update. So the only difference here is that the h1 node now has a child node with the value of 1. So we have a virtual DOM and a real DOM that's out of sync inside this update process. And what Vue or React is going to do, in simple terms, is compare each of the nodes. It's going to loop through this tree structure and compare the nodes to each other. And when there's a difference between the nodes, so here we're comparing 1 to 0, the framework will pick up the difference and update the DOM to match the virtual DOM's node. So that value has been updated to 1, and then we'll carry on diffing. And in this way, instead of updating the entire tree, we've just updated one node. So that's a factor of 6 times less work already. You can imagine in an application that has thousands of nodes, it makes a real big difference. So what we were doing, we updated the state by clicking on a button. and then somehow updating that state triggered the virtual DOM to be re-rendered. And then after the virtual DOM was re-rendered, we updated the DOM by comparing the virtual DOM to the real DOM. So we've been looking at Vue so far, and we've sort of got all the prerequisite knowledge in place. Let's just go through like React's reactivity system, because it's a bit simpler to understand than Vue's. So here's the same component rewritten with React. I've commented out the constructor and the increment method, but if you look inside the render function, we have a very similar looking function to what we had in Vue. We've got our div, we have an h1, we're using the state value of count inside the h1, and then we have an onClick method on the button that's going to call this.increment. And you can imagine that that updates the state and then triggers a re-render. So it's worth noting that inside this render function, you have this stuff that looks a bit like HTML. This isn't actually HTML, it's something called JSX, which needs to be compiled into JavaScript before it's run in a browser. And when you compile it, it looks like this. So really similar to our render function that we had earlier, where you have create elements function calls with a load of arguments that's ultimately describing how to create the virtual DOM. So this is the, you can see here the constructor where we set our initial state for the component. And then we have the increment method where we call this.setState. So this.setState is the key to reactivity in React. Once we call this.setState, it tells React that the state is updated, and React's going to go through the entire render process. It's going to update the DOM, the virtual DOM, by calling render. Then it's going to diff against the real DOM and update the DOM so that we have a reactive application. So that's React. And I think the main takeaway is that React's reactivity system is it's a pull reactivity system. So you need to give it an explicit signal to update. Otherwise, your component isn't going to do anything. So changing the state without calling this.setState or another method that tells React explicitly that it needs to re-render and go through the rendering process again, if you don't do that, React isn't going to be reactive. So if we look at Vue, Vue's a little bit simpler to look at. So in our component earlier, when we were updating the count, we literally just had this count increment value, which seems really simple on the surface until you start to think about how calling incrementing count triggers the whole re-render process. So to explain how Vue knows that updating a property is going to need to trigger a re-render of the component, you need to understand setters and getters. Just hands up, who's heard of setters and getters before? Okay, cool, pretty much everyone. That makes it a lot easier. So basically setters and getters are a way for us to proxy functions to be called instead of the default behavior. So if you look in this example, we've got this state object and we've added a setter for A. So when we call A with a new value, it's going to set the A that we have outside of the state. It's going to update that, and then it will console log that we set A with the new value. And then we can add a getter as well that's just going to log that you called getA when the component tries to get that value. So basically what Vue does to add reactivity is it steps through a component and it finds every single reactive property and adds it as a getter and a setter to the component. And then it keeps track of, so doing this, it keeps track of what properties are reactive and what properties changing and being set need to trigger the component to re-render. So earlier we had our counter, or our count property. When we originally instantiated the component, Vue will have made a setter and a getter for that count property, and therefore triggering it, updating the value, changing the value later, will cause the whole component to go through the re-render process. So I've just realised that I deleted a slide that explains the process a bit better. But this is this is the last slide that sort of shows how. I don't know if this makes much sense if you haven't seen the previous example, but basically that's the in and out of it. Vue walks through a component, creates setters and getters, and then by doing this can track what components need to re-render depending on what value has been updated. So yeah, thanks guys, that was like a really high level overview. So the question was, in the diffing process, do we actually go through every single node and compare it to the node in the DOM? And yeah, like you suggested, that would be monstrously inefficient. So that's not how it works. It's actually a lot more complex, and I don't think I have the explanatory powers to give you a good explanation of how that happens. It's very different in React and Vue. They both have different patching algorithms which diff the virtual DOM and the real DOM. But yeah, there is some trade-offs and some assumptions that both of them make that make it a more efficient process. Cool. Thanks, guys.